Hello, this is the first part of 6.1. We're going to be talking about polynomial graph properties. We're going to start off by filling in this table with some definitions and information that you will need this chapter. So the first one is the number of zeros for polynomials. Hopefully you know that. That is the same as the degree. And remember, the degree is the highest exponent. So if the highest exponent is 4, that means your answer would have, or your question would have 4 answers. For the maximum number of turning points, you take the degree and then you subtract 1. So again, if your degree is 4, the maximum number of turning points you could have is 3. It doesn't mean it has to have 3, it means it could have 3 turning points. All right, for imaginary solutions with real coefficients, if you have an answer that's imaginary, say a plus bi, so if that is a solution, then the conjugate, or the opposite side in the middle, a minus bi, is also a solution. So imaginary solutions come in pairs for your answers. So you're always going to have at least 2, but any multiple of 2. You could have 2, 4, 6, depending on your equation. Okay. Double roots on a graph. When we are graphing, a double root is when you get the same answer more than once. That's going to show up on a graph where the graph just touches the x-axis. So over in this picture to the right, a double root would occur where that red dot is here. So then your definition, if you want to add more description, that is a curve that has 1 point on the x-axis. So that would be a double root. Then our next one is a one solution on a graph, and that is when your graph goes through the x-axis. So if we add a picture up here, or you can draw a separate one if you would like, this one over on the left, that one would be a single solution or one solution. Okay. So a double root is a curve that touches the x-axis. One solution is where it goes through the x-axis at just 1 point. Okay, local maximums. So on our graph, we might have a maximum point, but local maximums are going to be maximums that occur, but they're not the final max. So let's see, if we draw a graph that looks like this, we can see that our graph will continue to go up over on the left side. So our maximum point is nothing because it will continue to go up. But we do have a curve here, and this point would be our local max. When you are listing your local max, you are going to list only y values. So list only the y values on your local maximum. Okay, next we have local minimums. Again, you are only going to list the y values. So if we were to draw a graph, let's go. Okay, so local minimums, those are going to be at the bottom of a curve. So this would be a local min. And your graph might have more than one local min or local max. So make sure you are finding all of them if you are asked for those. When you're asked to find the zeros, for these ones you only need to list the x values. So your zeros are when it's going to be touching the x-axis. That will give us our solutions. So if you were to draw a sketch here, let's make a graph. Whoop. There we go. So we have a sketch. So this one has zeros at, it looks like, -2 and then +1. So when you list out your zeros, at -2, that's a double zero. And then a single root at +1. So double zero at -2, and then a single root at +1. If it asks you to list your x-intercept, this is when you are going to list them as coordinate points. So if we use that graph from above, your x-intercepts would be at -2, 0, and that one's a double root. And instead of writing out double root, you could put dr, that would be okay. And then our other one would be at 1, 0. So it asks for the zeros. You don't have to put them as coordinate points. You can just put the x values. If it asks for the x-intercepts, those are talking about the points themselves, so we have to list those out as coordinate points. Okay, so then we have our domain and range. Those are our last two vocab words for this part. Your domain is your x values. And for our polynomials, the graphs will continue to go to the right and the left every time. So your x values are going to be all real numbers. And we can write it like this. This is saying that x is an element of the real numbers. So you can write it out like that. If you continue to put x is all real numbers, that would be okay. This is just a little bit faster with the abbreviations. For your range, that is your y values. When we are writing our range, if you have an even degree or an odd degree, that's going to kind of affect how you write your answer. So if we have an odd degree, we know that because of our end behaviors, one side of our graph is going up and one side of our graph is going down. So if it's an odd degree, your range would be y is an element of all real numbers because it's continuing to go up and down. When it's even, our end behaviors both go the same way. So this one is going to be an inequality with y. So it's going to be y is greater than or equal to a number, or y is less than or equal to a number. Okay, so that's all of our vocab. The next video will go over some graphing examples.